Assalamu alaikum, good day everyone. So today we'll be talking about the sodium chloride equivalent method, and before we proceed I want to tell you that we have these steps, step 1 and step 2, step 3 and lastly but not least step 4. So step 1 will be equal to the weight of the reagents times their E values. If they're individual or a lot of reagents we use this equation, and for step 2 we use 0.9 over 100. This will be in ml and this is in grams. Then we'll multiply it in the volume of our preparation. And step 3 is step 2 minus step 1, or the result of step 2 minus step 1. And lastly we have the step 4, which is step 3 over its E value. And step 4 is only used when the sufficient quantity is not sodium chloride. So without any further ado, we will proceed with the problem 1. How many grams of sodium chloride should be used in compounding the following prescription? All what we have to do is we'll put the step 1, which is weight times the E value. Then step 2, 0.9 over 100, that will be in ml, that will be in grams. Then we have step 3, which is step 2 minus step 1. Then finally step 4, which is step 3, which is a step 3 over its E value. So let's continue with this. So the weight of our reagent is 0.3, as we see here, and the E value will be found in this table here, which is for pilocarpine nitrate. Pilocarpine nitrate. Where's the pilocarpine? Here's the pilocarpine, and it is 0.23. 0.23. That's the E value. So it will be times 0.23, and we will yield 0.069. For the step 2, this will be times the volume. So 0.9 grams over 100 ml will be times the volume, which is 30 ml. So we will yield 0.27 grams. So that's step 2, and here is step 1. So actually this 0.9 over 100 ml is a constant, and it is taken from the normal sign, which is 0.9% of NaCl. So let's continue with step 3. Step 3 is step 2 minus step 1. So there's step 2 and here's step 1. So it is equal to 0.27 minus 0.069. And we will yield what we will yield from here? We will yield 0.201, and that will be in grams. For step 4, we must ask a question. Is QS NaCl? So if it is yes, so there's no need to use it. But if it is another one, as we see here, the QS, if it is other than sodium chloride, we should use the step 4. But in our case, we will not use step 4. The next problem, calculate the quantity of sodium chloride to be used in compounding the prescription below. So we have procaine hydrochloride, it is 1%, sodium chloride, it is a sufficient quantity, sterile water, the volume is 100 ml. Signal for injection. So as we did earlier, we should use the step 1, step 2, step 3, step 4, but as we see here we have the percentage. So how should we convert it into grams? So as we all know, the 1% of a substance is 1 gram in 100 ml. So we will use ratio and proportion. So we'll put here x grams, and here we will put the volume which we have here. So the volume here is 100 ml, and we will multiply, of course, multiply the ones closest to the other and the farther to the farther, and we will be yielding this equation. So x will be equal to this 100 will be here down, and the 1 will be here upward, times this 100. In order to calculate, I will cancel out 100 with 100, so I will yield 1, and that will be in grams. So this will be the weight of pilocarpine. So the weight will be 1 gram of procaine HCl. So let's start now with the step 1. So step 1 is the weight times the E value. So the weight of procaine hydrochloride is 1 gram times the E value. Let's search for the E value. So the E value for procaine hydrochloride, we'll find it here. Procaine hydrochloride is 0.21, 0.21, 0.21. So in order to calculate, we will yield 0.21 grams for multiplication. So that will be the answer for step 1. Let's move to step 2, which is 0.9 over 100. That will be in grams and that will be in ml, times the volume. So our volume, as mentioned here, is 100 ml. So we'll place it here, 100 ml. And this will be cancelled out of this, the ml will be cancelled out of ml, so we'll yield 0.9, and that will be in grams. So moving to step 3, step 3 is step 2 minus step 1. So we'll substitute the numbers. So 0.9 minus 0.21, which will be equal to 0.69, and that will be in grams. Step 4, let's ask our question. Is our sufficient quantity sodium chloride? So if it is sodium chloride, there is no need to use step 4. So moving to the next problem. Calculate the quantity of boric acid to be used in the prescription below. So as we see here, sodium chloride was substituted with boric acid. So our sufficient quantity here is boric acid, and we will use step 4 as our final calculation. So as we see here, the grams are ready already, so there's no need for ratio and proportion. So we'll proceed with step 1. So step 1 is the weight times the E value. So the weight is 0.06 grams times the E value. So let's search for the E value here for zinc sulfate, and it is 0.15, 0.15. So in order to calculate, we will yield 0.009, and that will be in grams. So we're finished with step 1. So let's move to step 2, which is 0.9 over 100 ml, and that will be in grams, times the volume, which is 30 ml. So 30 ml. So ml will be cancelled out of ml. Then we will calculate, and we will yield 0.27 grams. So moving to step 3. Step 3 is step 2 minus step 1. So let's substitute the numbers or the values. So 0.27 minus 0.009, and this will be equal to 0.261, and that will be in grams. But as we see here, the sufficient quantity is boric acid, and it is not sodium chloride, so we should proceed with step 4. Step 4 is very easy. Step 4 is step 3 divided by its E value. The 0.261 is the answer for step 3, and the E value is, as we see here, for boric acid. We'll search for boric acid here. So boric acid E value is 0.5. So let's put here 0.5. And for the calculations, we will end up with 0.522, and that will be in grams. And here's our final answer. So moving to number 4, or the problem number 4, how many grams of boric acid should be used in compounding following prescription? So as we see here, the sufficient quantity is boric acid, and it is not sodium chloride, so we will be using step 4. And the reagents here are 2, and they are both in percentage. So that's something tricky. So before we start with step 1 through step 4, we should use proportion and proportion. So 1% will be 1 gram for each for 100 ml, and the ratio will be to x gram, and our volume here is 60 ml, so we'll put here 60 ml. Then we will cross multiply, and we will yield x will be equal to, here's 100, and the 1 times the 60. So we will be having 0.6 grams. So that will be the weight of phenocane hydrochloride. As of for boric acid, or not for boric, chlorobutanol, the proportion will be discussed here. So it is 1/2 or half, 1/2 grams to 100 ml. Then the ratio is to x gram every for each 60 ml. So we'll cross multiply and we will yield x will be equal to 100 will be down here, and 1/2 is here, times 60. So we'll be having the value 0.3 grams. So here we've got the weight of chlorobutanol. So after doing this, we should get their E value through step 1. So step 1 will be divided into 2. So we'll have 1, which is the phenacane hydrochloride. So the phenacane hydrochloride is 0.6 grams times its E value. So we'll search for the E value. It is phenacane hydrochloride. Phenacane hydrochloride. Phenacane hydrochloride is 0.2. Its E value is 0.2. 0.6 times 0.2 or 20, and that will be equal to 0.12, and that will be in grams. As for the chlorobutanol, we have the step 1, but number 2 is equal to 0.3 grams times its E value. So let's search for the E value of chlorobutanol. Chlorobutanol is here. So chlorobutanol is 0.24. 0.24. So 0.3 grams times 0.24, and we will yield 0.3 times 0.24 will be equal to 0.072 gram. After that, we will add both these together. So we will yield the following number: 0.192, and that will be in grams. So here's the answer for step 1. So let's proceed to step 2. Step 2 is very easy. It is 0.9 over 100 ml, and here's grams, times the volume. So what is our volume? It is 60 ml. So 60 ml. Then we will cancel out ml with ml, and we will yield 0.54, and that will be in grams. So moving to step 3, we'll take step 2 minus step 1. So we will have 0.54 minus 0.192, and that will be equal to 0.348 grams. And here's our answer for number 3. Moving to number 4, because our sufficient quantity is boric acid. So as we know earlier, the step 4 is step 3 over the E value. So our sufficient quantity is boric acid. So as we all know, the boric acid's E value is 0.5. So 0.348 over 0.5 will give us 0.696, and that will be in grams. So to conclude our topic, we have this the sodium chloride equivalent method, and we have these 4 steps: step 1, step 2, step 3, and step 4. Step 1 is the weight times the E value, and step 2 is 0.9 grams over 100 ml times the volume of the preparation. Then step 3 is step 2, or the result of step 2 minus step 1. Step 4 is the step 3 over its E value, and it is only used when the sufficient quantity is not sodium chloride, or our QS is not sodium chloride. So thank you for watching, and I hope this video helps you a lot in your studies.